BricsCAD Mechanical for welding. BricsCAD Mechanical provides an intelligent, flexible, accessible, and cost-effective ways for manufacturers of any size to reduce concept to fabrication times. If your business is looking to automate your processes, become more competitive, and build better, then you should be looking at BricsCAD. Welding is essential in many manufacturing sectors. The ability to reduce fastener count and assembly effort, as well as the opportunity to permanently fix multiple parts into a single component, is often the best way to optimize a design. BricsCAD is a client-centric CAD product. This means that we rely on our feedback from our customers to help us define the direction of our products. So if welding is essential for you, then it's a key requirement for BricsCAD. Part of our efforts to help our clients streamline design to fabrication productivity, with BricsCAD Mechanical V23, we've enhanced our fabrication support tools. You can see this in both our already industry-leading sheet metal capabilities and in our new introduction of 2D and 3D tools for welding definition and documentation. In this demonstration, we'll walk through the new capabilities added for welding. The welding tools in BricsCAD Mechanical are included as part of the annotation toolset. 3D weld bead definition is incredibly simple. First, execute the BIM welding command or select a weld type from the symbols menu. Next, select the to surface where the weld will be positioned. And BricsCAD Mechanical automatically inserts the 3D weld bead. Based on customer input, BricsCAD Mechanical V23 supports fillet and groove weld definition, as these are the two most common types. The 3D weld bead in BricsCAD Mechanical is a fully supported 3D component. This means that it has properties such as size, length, mass, and material types. Properties information regarding the weld can be viewed in the mechanical browser. This data also rolls up into the bill of materials. We'll review this a little later in the demonstration. Here's another example of the simple process for design layout. First, switch from the design phase in model space to the detailing phase in paper space and begin creating views and details needed for production. Just select the view type and position the view. Done. You'll notice that the graphics for the weld geometry appear in each of the views and details. Let's zoom in so you can see this a little better. Again, this is because the 3D weld bead is a true component and it's displayed properly in every view type. Once we've laid out the views, what we want to do next is to annotate the weld in paper space. The process here is also simple. First, select the Annotate Weld tool from the Symbols menu. Next, select the view type, top or side, and then select the location in orientation to place the weld annotation correctly in the view. Once the annotations are in place, use the Properties panel to validate or update the size of the weld annotation. This part of the job is done. The side view annotation process is the same for groove and fillet welds. The top view annotation, the process is only slightly different. Here, you'll need to specify the beginning and end points for the weld bead orientation, or the caterpillar. You may need to use the flip tool to position the bead graphic properly on the part. Once the weld annotations are defined, you can complete the manufacturing communication process by adding the appropriate symbols on the drawings. This part of the process starts by selecting the drawing template that matches your company standards. Next, you'll input the weld symbols. Enter the weld symbol command or select the symbols from the ribbon. Select the geometry where you want to attach the symbol, set the symbol location, and finally, walk through the dialog box to define the values for the symbol. In some cases, you'll see special keystroke commands that help produce the annotations quickly and easily. For the last part of the demonstration, we'll review the way that the weld information is captured and manipulated in the BOM tools. The goal here is to provide the fabrication team with an estimate for the weld material or rods needed for the project. First, we want to filter out all solids except for welds. Next, we're going to add BOM columns for weld type, size, length, and the physical properties of the weld material. We'll delete the component column since that information is not part of this exercise. And now we'll add a footer and use the sum tool to capture the total amount of weld length. We'll rename the BOM table as the weld table, and then we'll insert the BOM on the drawing. And that's it. The weld information's been defined and completely documented in the drawing. We'll add a few balloons to help communicate between the designer and the fabrication team, i.e., put weld here, and we're done. BricsCAD Mechanical provides manufacturers with the 3D and the 2D tools needed to optimize designs for producibility and to streamline the design to fabrication process. We hope that you found this demonstration helpful. If you have any questions or if you'd like to try the software on your own project, please visit our website. You'll find answers to most questions as well as access to the free, no obligation software trial license. Thank you for your attention.